A hot metal bar is brought to a room of constant temperature. It is known that after the metal has been in the room for T minutes, its temperature is given by this, for some constant A. What's the temperature of the room? Well, if we let T tend to a very large number, clearly this term is going to completely disappear, because e to the negative, a large number, will be very, very small, close to 0. So the temperature of the room is clearly 23 degrees Celsius. We want to show that y satisfies the differential equation given here. That's just a matter of substitution. dy dt would be, the 23 will disappear, and then what we'll have here is negative 0.04 a e to the negative 0.04 t. Substitute into here and we get negative 0.04 a e to the negative 0.04 t plus 0.04 23 plus a e to the negative 0.04 t, take away 23, so that's negative 0.04 a e to the negative 0.04 t. These 23's cancel, so plus 0.04 a e to the negative 0.04 t is equal to 0. If the temperature of the bar 10 minutes after it is brought into the room is 115 degrees C, show that A is approximately 137 and find the initial temperature of the bar. So, what we're being given is that Y is 115 when T is 10. So AE to the negative 0.04 times 10. So we just need to solve this, and we can do that on the calculator. So what we want to do is solve, and we have 115 is equal to 23 plus, let's call it x, and then we need e to the negative 0.04 times 10, and we'll just solve that and we get 137.24 and so on. This one shouldn't be approximate, so let's just make that into a proper equal sign, and then we can give approximately 137. So we now know that y is equal to 23 plus 137 e to the negative 0.04 t when t is 0, which is the initial temperature. Y is 23 plus 137, and that would give us 160. What was the instantaneous rate of change in temperature when the bar was brought into the room? So we need to differentiate. dy dt is going to be negative 0.04 a e to the negative 0.04 t. We know that a is approximately 137, and when t is 0, we know that this will all be 1. So it's just a case of working out 0.04 times 137 That gives us 5.48, so negative 5.48 degrees Celsius per minute. Determine the time that elapsed for the temperature of the bar to drop to 2/3 of its initial value, giving your answer to the nearest second. So the initial value we know was 160, so we want 2/3 of that, and that's going to be equal to 23 plus 137 e to the negative 0.04 t. So once again, it's just a case of solving on the calculator. I'd probably use a more accurate version of the 137 since we're going to the nearest second. So again, we want to solve, and we want 160 multiplied by 2/3. That's going to be equal to 23 plus, so let's use the more accurate version of this. Let's drag it down here and multiply that by e to the negative 0.04 times x. And we'll solve for that, and that gives me 12.3736. And that's of course minutes. So to get the number of seconds, the thing to do is take the 12 off of this, and then multiply this by 60. That gives me 22 seconds. So it's 12 minutes and 22 seconds.